Today we will be building and squaring a 3D printer frame. Hello everyone, Chris here. Squaring a 3D printer frame is important for a lot of reasons. And I've seen in the comments a lot over the years that I should make a video on how to square a 3D printer frame. So that's exactly what we're going to do today. Now, since a 3D printer is a machine that depends a lot on how level the nozzle is to the bed, you can imagine how squaring the frame would greatly help you achieve the results that you want out of your 3D printer. And there's a lot of factors here, and there's a lot of different ways to do this, but I don't think it needs to be a complicated process. So we're going to walk through it step by step. And remember, when I say squaring a 3D printer frame, there's a lot of extrusions or different frame pieces that need to be an equal length, and they need to be square with one another. So imagine you have a square frame. Each one of the angles of those corners need to be a right angle, or 90 degrees. That will ensure it's square, and then as you build the frame, everything will be true so that you get the best results from your machine as possible. So let's jump right into it. We're going to take a look at the extrusions that we're going to use today to build our frame. This is the frame for the Muldex IDEX 3D printer we're currently building on a live stream series. When I build a 3D printer, I like to get all the frame pieces out and line them up and put them in order. It's very common still to see aluminum extrusion being used as the frames. A lot of these kits are going to be exactly like this, just different lengths and different shapes. Most of the Muldex is 2040 aluminum extrusion, but again, I'm going to line them up by height, and then I'm going to try to match them up. Because the most important thing about this whole process is that the extrusions that are supposed to be the same length are identical to one another. Depending on how they're fastened, a lot of these are fastened in the end on a blind channel. I'll show you that more later. But these have to be identical or the frame is never going to be square. So I line them all up, and I'll just get my straight edge and put them on the extrusion end and just give them a little push, so they're all aligned. That way it's much easier for me to see if all of these are the same length. If you take a look at these four here, these are for the Z uprights, so they all need to be identical. You can just kind of by eye match these up. If we zoom in from the side and just take a look at that edge, you can see that all four of those extrusions are the same length. So we know the extrusions are good quality, we're in good shape to continue building. But do that with any extrusion that's going to be equal size. On our build, we have the Y pieces. All of those will be equal. We're going to match all of those up to make sure they're correct. And the pieces that you can't match up to make sure they're identical, any printer kit nowadays is going to have a bill of materials that you can go check out the sizes. The Muldex project has great drawings. You can come in here and figure out how long those pieces are going to be, and then you can measure them to make sure they're accurate. But even something like the Ender 3, they have a GitHub page that tells you exactly how big all of those extrusions are supposed to be. And depending on the results, then you can take action to try to correct that. And the most accurate way to tell how long an extrusion is, if it's the correct length, would be to get a set of calipers. But a lot of these are going to be way too long for any calipers that we might have around. So your best alternative is something like a measuring tape. And for instance, we'll focus on these Z extrusions. If we take a look with our tape, that is exactly 505 millimeters. We go back to our drawing. Number 5 here is that Z vertical extrusion. You can see it up here in the list. He's got it measured out from the top frame up here, so 20 additional millimeters because this is 2040 extrusion. So 525, 505 plus 20, that's exactly how long it should be. So it's a great idea to go through and spec all these out before you start building. So this is a great idea to do this on anything that you build. Before you start, make sure everything is the proper length. The kit quality nowadays is really high. You're not going to run into a lot of instances where this is going to be a little bit off, like we did even 5 years ago, but it's great to check. Now, if you do run into something that isn't accurate, you could try to cut it down yourself if it was just a bit too long. Or you could try to order another piece of extrusion and cut that to length to get it a little bit more accurate. If you run into something where there's more than 1 or 2 pieces that are a little bit off, just go ahead and send the whole thing back and start over. But on something like an Ender 3, if it was just a little bit off, or even if the cut wasn't exactly square, you could try to square that up yourself with a saw. I usually use a miter saw, something like that, on aluminum. Given an Ender 3 is a very low-cost kit, you're going to be willing to sacrifice a little bit here and there and try to square it up yourself. But now let's move on to some of the tools you might want to use while you're squaring your 3D printer frame. And I will say it again, for all the folks out there that do this frequently, there's a lot of different ways to do it, a lot of different tools, but it doesn't have to be that difficult. First off, to get a rough idea, a tape measure is always a good idea. Like I just showed you, this is a metric and standard tape. These can be found pretty inexpensively anywhere. Try to get a somewhat reputable brand so it is accurate. If you have more than one tape, consider comparing them to one another, because not all tapes are created equal. But that's always handy to have. From there, you're going to want something they call a carpenter square. Basically, it's just a 90-degree angle that we can use to compare up against our frame to make sure that it is square. These are really handy. Get a metal one so that you can clamp it down. You don't have any risk of it being plastic or something like that and causing an odd shape. But you can also use something like a speed square if you don't have a flat carpenter square like this one. These little squares as well, same kind of thing, only it fits in tighter places. These can be really handy. Getting really tight corners, you can ensure things are square even if you can't get to it with your larger square. A nice flat metric ruler is never a bad thing to have. This can help you out while you're building, but it's also a nice flat straight edge. And then every project, I like to include some Irwin quick clamps. These can be really helpful when you're trying to clamp together, get things all in position before you screw it down while you're trying to square things up. You'll see that here in a moment. And then something like a very large straight edge is always really handy, because the next thing we're getting ready to talk about is the area that you use, your bench top, wherever you're building, where you're going to square that frame at. It should be pretty flat. Somewhat square maybe would help, but mostly just flat to build upon. So the list of tools isn't very long. It's not a complicated process. You just have to know how to do it, what to look for to get everything nice and square. Now, the thing that I have found most important over the years is the location where you're squaring your frame at. This table here that we use for all the videos, it's very inexpensive snap-together flooring that we replace once in a while. It's not necessarily the flattest thing in the world. So you want to make sure the surface that you're going to build on is relatively flat so that it's easier to square things up. Now, it's not a have to. You can compensate for an unflat surface, but it's going to make your life so much easier if you already have one. That's why using something like a marble countertop, just a section, quartz, anything stone that's already going to be super flat is going to be really helpful if you build upon that instead of a wood surface. And how do you check if your surface is nice and flat? I can tell you right now, because this is snap-together flooring, there are two different sections of flooring here that meet on this crack. Where they've been pushed together, it's not very flat. But that's where a straight edge, longer the better, this one's about 4 feet, really comes in handy. You can put it across your build surface and just see how flat it might be. Now, if there were a high section in the middle, you could feel this teetering. But really the easiest way to determine how flat it might be is with a piece of paper. So if you stick that under your straight edge, you can use this paper as sort of a feeler gauge to see where it gets tight. We're tight down here. It's very loose in the center. And we're tight down here on the edge again. So we actually have a bow to this countertop. So it's a little deeper in the middle than it is on the edge. That's not a great thing to build upon when you're trying to straighten up a frame or square anything. So now we can go to the countertop to lay on top of this that will be very flat. And I'm going to get a hernia. So this is just what's left after they cut a granite countertop. I got it from my local hardware store for $10. They are very heavy, but they're going to be pretty much 100% flat, just how they make these things. And you don't necessarily need a countertop that's this size. You can build your frame in small sections, still using this to square up next to. But a bigger one is always helpful if you can keep from rupturing yourself while you're lifting it onto your table. But now if we get our straight edge on here and a piece of paper, you can see the difference. We're very tight in the center, as well as down on the edges. And you can't feel anything causing the straight edge to teeter. So we know this surface is very, very flat. And you can check it multiple directions, but there are no issues with this section of countertop. This is going to be a great surface to build our printer on. You also want to make sure whatever surface you're going to use is nice and clean. You don't want any remnants of what you were building before to be causing any skew as you're trying to square up your frame. But now we can start building the frame and making sure it's square. Of course, you want to go by the manufacturer, how they intend for you to build the frame step by step. But as you go, you can use this as your source of truth. You know it's flat, and then you can square up the frame based on how it's arranged on your countertop or whatever you're building on. And I'll show you step by step how I do it. So on the Muldex, we start with the top of our frame. So some people call it the halo, but it's the extrusions that set on the top that start the build. And then we kind of build upside down. So all three of those sections, because of how the Muldex is, it's actually a little wider than it is deep. They're all the same length, and I'll show you how that's compensated for as they butt them up together. But this is a great place to start because we have this nice flat surface. We can build it here and ensure everything's going to be square. And remember, aluminum extrusion isn't always perfect. Now that you have your flat surface, you can use that to kind of tell what kind of shape the extrusions are in. Check out multiple sides of these extrusions. They're not all extremely flat. Set it up on its edge, teeter it a little bit, just to see how flat it might be. You're never going to get anything that's perfect, but within reason, you should be okay. Really, the length of the extrusion, in my opinion, is a lot more important, having that accurate, than maybe necessarily so straight, but it needs to be pretty close. So this section, you can see I've already got the screws in it. We're using blind screws. I'll show you what that means here in a moment. But this is the top section, or the back of the machine. Remember, we're looking at the printer from up above. And then our left and right pieces just slide onto those screw heads. We'll do this one over here too. And then you're going to use your wrench from the side to snug those up. That screw head inside this channel of this extrusion is going to pull up against it and fasten it in place. Now, what I like to do, since we're coming through this extrusion to get to that screw head, is just lightly screw these together. You don't want them to be snug at all. We're just going to get them in place where they need to be. In fact, you don't want to tighten these up because in this configuration, that screw head inside here is actually going to indent this extrusion a little bit inside that channel. And going forward, that screw is always going to want to go to that spot where you tightened it up before. So just snug them up for now. We still have a little play where we can move the extrusion. That's good. And then we can square it. So here comes our carpenter square. Now, the first thing I want to do, because there is the ability to have a little bit of slop, since there's just screw heads in the inside of this channel, that you could move this extrusion up or down. We're snugged up just a little bit, remember, but I'm going to go on the outside of the extrusion. Just to make sure, I'm going to press these both kind of out and up against that square so that I know that this one is flush with the top of this extrusion. Then I'll go to the inside. For the inside view, this is the part where you really start squaring the frame. You want to make sure that your carpenter square meets up with your extrusion and there are no gaps around the extrusion frame with that carpenter square. It needs to be completely flush. If you can move that carpenter square around at all, then there's something that's out. Either one of these has been skewed or you don't have it quite centered. Maybe this cut isn't flush. But this should be completely 90 degrees inside here. Your frame should meet up with it. Now from here, what I like to do, now that I know that these are square, everything's good, we're flush on the top, I like to clamp these before I snug those screws up on the outside. And another nice part to using these countertops to build on is you can get a little creative with how you utilize them. I can't get around to all the points in the table to clamp things, but I can pull the section off just a little bit so that I can clamp it in the corner, and I can work from there. So again, I'm square on the outside, and we'll very carefully move to the inside. we're square. So that means from the outside, if it's flush, everything should be square, ready to fasten. So I'm going to use this as my placeholder to make sure that they're flush. I'm going to clamp this top extrusion in place so it doesn't move around anywhere. Don't get crazy with it. Aluminum can get dented, but you should be okay. Square up that outer one more time, this extrusion right here. We'll clamp it in place. Now both extrusions are clamped down. They're not going anywhere. Remember, don't get your clamps too tight. We're just trying to keep these from moving while we screw them together. They can skew your results. They can pull that extrusion one way or the other if you get them too tight or don't get them positioned correctly. But before we tighten those screws up, remember we're going through this back channel into this one to get them tight. We're going to use this square one more time on the inside to make sure everything's good after we clamped. And then we're good to go ahead and tighten up these screws. Remember, after you've tightened them once, it can leave an indent on the extrusion where that screw always wants to go back to that spot. But clamping them like this could help you get it to the proper spot if you've already done that. So now we know this joint right here is completely square. And then we can move on to the other side. So now that we know that that other side is already square, it's already snugged up, just repeat that process outside and inside. Make sure that that outside, both of those extrusions meet up. Remember, press on them a bit to make sure they're square. Move to the inside, then clamp it, and then you can snug up those screws. It's hard for me to show you all this to get to the edge of the table and do all this process, but keep this flat until all of your components are together. You don't want to risk lifting this up and skewing it a bit if you don't have to. So if you need to move the frame to get to it to clamp it, try to spin it around on your countertop or whatever you're working on to keep everything flat and in place until you get everything snugged up. But we'll make sure this joint is square and we'll go ahead and snug up those screws. So now we have both of these fastened. Remember, this is the top of the frame for the Muldex, but it's nice and flat on our countertop. We know that it's flat and it's square, and this will be the source of truth as we start building from here. Now this works for this design. It might not for everyone, but try not to move this piece out of square until you've built some of the rest of the frame to help hold it in square. We will do a square after we get it built, but I'm just trying to get you started in a good spot. And remember, you're not going to be able to do this process on every 3D printer exactly the same way that I am. I'm just trying to show you what you're looking for, what tools to use, and how to use them. But one of the key things is, as you're building, try to keep it in the same location. Don't move it around too much. Don't pick it up. That could get it out of square, and then you're going to have to start over again. Now, squaring it while you build is great, but you're going to have to do a final square after you're done just to make sure everything's in order. But hopefully, if you're doing it this way, step by step, you won't have much to do at the end. So let's continue building from here. Again, this is our top, so the printer is currently upside down, if you want to look at it that way. And then we can put our Z's on here. So now we have another direction to keep track of while we're squaring. But we know this part of the frame is already nice and flat. So from here, we have our 4 Z verticals. They're going to go on just like this. So now we have to keep track of that vertical measurement to make sure it's square as well. So we'll just start in this corner because that's the one we can see on camera right now. But we've got through holes in this extrusion. Again, we've got blind screw heads. They're just going to slide in this channel, and then we can start to square it and line these up as we build. So again, I utilize my table and my countertop to pull these off the edge a bit so that I can get to the screw heads, but maintaining this on my flat surface as much as possible so it doesn't get skewed. So from here, I can take my frame to the table edge, just enough that I can snug these screw heads up. Remember, don't get them tight. We just want to make it a little more difficult for this thing to move around. And then we can work on squaring it up. So again, from here we know this part of the frame should be pretty flat. If you use your carpenter square, we're going to go this direction. And I like to use the outside of the extrusion. There's channels inside here where you could put your square in, but those are usually V channels. It might not land on a good solid spot, so I pick the outside of the extrusion. And we're just going to butt it up against our Z, to see just how square that might be. And I'm just going to set my square up here. I'm going to try to let you see what's going on here. What you're looking for is you don't want any gap in your square down here on the bottom. You want it to be completely flat up against that extrusion, and the same as it goes up on the Z extrusion. And if I hold my paper up back here, you can see that there is a gap. Barely see it, but you can see my paper moving around in between your square and this Z extrusion. Now, it's going to be almost impossible for you to get this 100% correct without the rest of the printer being built. But just taking a quick look at this to make sure that everything's somewhat square is a great thing to do. This will at least tell you how flush the cut was when they cut this extrusion. This being in open air up here like that, having that small gap, it's still pretty square, but as we get it together, it will be perfect. You'll see that. But we want to do it from this angle, as well take it around to this side, and check this angle. Again, I'm on the outside of the extrusion. And we're going to have the same thing here. Again, that's not too far out, but without the frame being completely built, it's going to be really hard to see that this is completely square vertical. When the top frame goes on, if everything is square when we build it, that will correct this issue. But we have already seen that everything's in pretty good shape. There's no oddball cuts. The extrusions are pretty true. So since we can't 100% confirm that this is going to be completely straight, the best we can do is make sure that it's nice and flush on our already flattened frame here, the top. And I just use another piece of extrusion. You could use something like a 1-2-3 block, but if you don't have that, another extrusion from the kit's going to be just fine. But I want it to be as flush as possible on both sides. So we've already snugged the screws up a bit, but you can still move this extrusion around. That's what you want. I want it to be nice and straight on both of these extrusions. So I'm going to take one on the outside, and I'm going to use my clamp, and just clamp that in place up against our frame that's already square, and then pull this extrusion back so it's nice and snug up against the extrusion I clamped on here. And then you can do the same thing for the other side. Just another piece of extrusion from the kit. We'll clamp that up. We'll push this extrusion we're getting ready to tighten up as far as we can go against that extrusion we just clamped on. That way you know it's nice and flush. It's going to be flush with this bottom piece we've already built. And once that's in place, go ahead and tighten up your screw heads. Once those are tight, we can go ahead and take our clamps off, remove our helper extrusions. And now we know that this section for the Z is in perfect place on the outside of the frame and down the side, so we can move on and do the same thing to the other 4 Z frame parts. Now I've got all 4 of my Z sections on already, but I did want to mention this. So when you run into an occasion like this, you don't have an extrusion here to clamp to. So you can clamp one over on this side and make sure that this is snug. It's square with this bottom extrusion. But you really can't clamp anything over here because you don't have a piece that's square. Well, in that case, trust the cut of your extrusion. Trust that it is nice and flat. Confirm that it is flat. It's been cut square. But then trust that to do your clamping. So in other words, to make sure that this is flush with that edge, use a piece of extrusion or a 1-2-3 block. Clamp it up against that cut, that square cut. You can just do that with one of your clamps like this. But that will be flat enough, that square cut, if it is square, to ensure that you can pull this extrusion back before you tighten it so that it's nice and flush with your extrusion. Now, if you are cutting your own extrusion, you need to make sure that your saw is able to cut that extrusion square so that you can do this kind of thing. And I realize again that there's a lot to this, and it's a bit of a snowball effect. One has to be square or straight before the other one can be, so we're building upon this. But let's go for some bonus footage here. If you are cutting your own extrusion, there's certain things that you can do to get your saw set up to make sure that you're cutting nice square parts. So out here in the shed, if I'm cutting extrusion, I don't like to if I don't have to, but I use a miter saw. These saws can usually cut anything that's non-ferrous, that it cuts that aluminum just fine, but you can set up your saw with something like this, a digital angle gauge to make sure that those cuts are going to be nice and square so that the rest of your project goes well. All you do is you turn it on and you put it on your table, And then you can zero out your table to make sure it is at 0. Once it's zeroed out, might want to give it a couple of tries just in case you moved it while you were zeroing it. When you're happy with that, stick it on the side of your saw blade. Make sure your saw is unplugged, of course, but you can see my blade is setting at 89.8. Then from there, you can adjust it to make sure it's a perfect 90 degrees. All these saws usually have an adjustment. Mine is down here. We need to crank it just a little bit so that we can get it to 90. That way you will know that all your cuts are going to be nice and square. I just loosened it up and pulled it over just a bit. Now we're at 90. We're ready to make cuts if we have to. So now that we know the top of the printer has been leveled on our countertop here and the Z uprights are on, we do have to move the frame. Now, I don't like to move it unless I have to. This design we will have to. But now we need to build the bottom section. We're going to build it exactly like we did the top section. Then we'll flip the frame over and attach it. But another great scenario where we can check and make sure everything's nice and square before we snug all the bolts up. So for now, I'm just going to carefully slide the frame that we've already built off onto the top of the table. We'll come back to it in a moment, but we do have to flip it over. But I don't want to skew it any more than I have to while moving it around. It should be good. All the screws have been snugged up, but, you know, be careful. So again, now we're building the bottom of the printer. We've got the back section and the two sides. We've already confirmed everything's the correct length. All the cuts are nice. We'll just slide our parts together. On this one, again, we do have blind holes. We got to make sure we have the right side. You can see these here. That's for tightening up the screws that are on the inside of these extrusions right here. So we can slide these in place down to those holes that we use for tightening. We'll do this side as well. And a tip that I can give you on something like this, where you have those holes that allow you to tighten those screws, I just like to use the wrench as a general guide of where that needs to be located. So I'll stick it in the hole until I can get a grip on some of the head of that screw. And I'll just give it a little snug. Again, we don't want to tighten it yet. We're just trying to keep it from moving around so much. But that's going to give you some indication of an approximate location of where those extrusions go. Then we can work from there. We'll do the same on this other side. And then once those are snug, we know from the drawing that it's 60 millimeters from the back edge of this extrusion to the face of this one. So then we can get it lined up perfectly. Now again, going back to your basics, these are snugged up. Everything is nice and flat on your build surface. So everything's lined up there. Then the same process applies. Carpenter square on the inside. Make sure that's nice and square. And then start to measure the distance to this extrusion, to the edge of this. Make sure it's a perfect 60. If you're using blind holes like we are here, they're going to be pretty accurate. Just make sure whoever made the frame didn't create a giant blind hole for you to be able to access, just one big enough, and it should be pretty accurate. But make any adjustments that you need to with this extrusion that's just snugged up. You can slide it forward or back just a little bit if you need to. Make sure this is the perfect measurement. Measure the top face of the extrusion and the bottom if you have a crucial placement like this. I'll try to get you in closer so you can see what's going on. This is the back of the machine, again, like we just saw. This might be a great place to use your calipers if you have some, but the way this frame is designed, I'm pretty confident those holes are going to get us lined up where we need to be. We are dead on 60 millimeters right there. But before we tighten the screws up, I'm going to do the same thing. I'm going to clamp down, and then I'm going to clamp right on the face of this cross extrusion to make sure that they're all square with our countertop here. Then I'll snug up the screws. It's a good idea to measure one more time after the clamps are on to make sure you have the right placement. Preferably you only do this once and then tighten up those screws. We're good there. We can flip around to the other side. Again, checking to make sure with your square that there's no gaps. You can't move it. It is perfectly 90 degrees. Do it on the outside as well. We're good. That's a nice square 90-degree angles, both sides. We'll flip to this side, put our square in here just to keep it aligned up. We'll measure it to make sure it's the proper distance. Make any adjustments to that length that you might need to when placing an extrusion like this. When you're ready, clamp down. Remember, these screws are snugged up, so you shouldn't have to apply any force this way. The screws will do that as we tighten. I'm going to clamp right on that joint, and then we'll snug up the screws. With that, measure again. Make sure it's nice and square in there. Do the outside. We're good. And then once again, we'll measure our distance here to make sure we're 60 millimeters from that edge. And it looks good. So now the bottom section is built. So when you're building a printer, this is the part where it gets a little bit tricky because we have to build and move things around as we make the frame. But again, that final square is going to help you with that. But this is our bottom section. Then we'll take the frame section that we built before and we're just going to flip it 180. Again, just be careful. Don't bump it on anything. Don't let any of the weight of the frame hang by itself while you're moving it around. Try to keep it within tolerance. Keep that square going. And we're just going to set it on the screws on our bottom frame section. Now we have that top section set down in all the channels. All the screws go into our bottom section frame. And since everything was built square on top of this countertop, we know our bottom section is flat. And all the faces on our Z uprights here, they're all nice and flush, setting on the countertop. So we know they're nice and flat, everything should be square. Now snug up all of your screws, again, don't tighten them. From here, now we should be able to trust the countertop is nice and flat, so you could measure square from the counter with your Z upright. Also, you're going to measure it from extrusion to extrusion. That's the most important part. But since the Z uprights are now confined with that bottom frame, everything should be square. So if you take a look here, remember before we saw that paper, we're going to go to the outside and we'll just give it a rough check. That looks pretty good. As we snug up the bolts, it's going to be a little bit more square, but check everything real quick to make sure everything's still in spec of where you think it should be. Come back here up to the top. Make sure that's still square, and do all the other corners as well. Now, it might not be dead on quite yet, but it will be shortly. So from here, remember the method that we're using. I'm trusting this countertop is nice and flat. We're building this frame to that to make sure everything is square. That saves you a lot of measuring going forward, but we're going to keep on with that method. We can make any tweaks we need to later. But we need this is still loose, right? We just snugged it up. We need the Z to be attached to this bottom frame. So we're gonna have to snug the screw up from this side. From this method, we are sure that the countertop is flat. I just want to make sure that this extrusion is nice and flat on the counter as the same as this one is, and it's not going to move left and right. So it's flush with the outside of this extrusion, the outside of this one. So we'll clamp it to make sure that's the case before we snug it up. So I'm going to clamp this outside extrusion in place onto the counter section. Remember, don't get carried away with the clamps. This is just to hold it in place. If you torque these down too much, you don't have them quite right on the metal, you could skew it. And then from here, it's going to be really hard to see because of the way I have to do this. I've got it off the table a little bit to use the clamp. You can use another piece of extrusion, but remember I said you could also use something like a 1-2-3 block, 1 inch, 2 inch, 3 inch. These are definitely flat. You can trust these, but you could put something like that, again, or another piece of extrusion on the outside here and then clamp that in place. That will ensure this is flush with the outside of this. So we'll just clamp that. And it's probably going to move this extrusion just a bit. But now we know that assembly is flush. We are flush down on the bottom. Press down on your frame, down on this section, and then you can go ahead and screw them together. After that process is done, take your clamps off. Do another check with your square, but you should be in really good shape. That's as square as it's going to get. And then we can repeat that process for all 4 of the legs. So the assembly of the frame is pretty much complete. There are other things that go on the frame, like the holder for the Z screw in the back, but nothing that's going to keep the frame square, keep it rigid. So now is a great time to go around and check and make sure everything stayed square in place, everything's meeting up with the other assembly that we put it together, all that good stuff. Run around with your square and make sure that we're in a good spot before we continue. And that process is simple enough. If you have the drawings, you should have the drawings for your kit so that you know how long things need to be so that you can check them. First thing, just make sure all the things we measured before are still in place. Your square here, your square down here, as well as square on the top of the frame. You're not going to be able to see this, but lay it in here on top and down here on your countertop surface. Make sure that is still square. Check all the angles, make sure there is no gap in between that extrusion and your carpenter square. If all of that checks out, then you can proceed to do some measurements to make sure everything is where it should be. Now, if it doesn't check out, loosen up the screws, go back through the process. You don't have to tear the frame down, but let's say this wasn't square. We measured it right here, and there was still a bit of a gap. Loosen up these screws, take multiple measurements of what might be causing that. Maybe it's not square down here. Maybe the surface that you were building on wasn't quite flat. But loosen up those screws, get that part loose, get it back in square, use your clamps. You can even use your clamps on the square to try to force that into square, clamp the square on, and then tighten those screws back up. It's just a matter of playing with it to get it to where it meets up with this square. Don't kill yourself. It's not going to be 100% perfect, but it has to be pretty close. And I know every printer isn't going to have this much information available on it, but if it's a kit, higher end printers now, they do have all this info. But take some of these measurements and take them for yourself to make sure they all equal up. So for instance, this measurement right here. The front of the machine should be 635 millimeters across. And then we have 525 high. And that's really the best way to make sure that your printer is square with itself. So we'll just take quick measurements across here. That is as close as 635 that you can get, but also we measured across the bottom to make sure that it's square, measure across the top. Again, 635 dead on. Take that same measurement that we saw before vertically. It should be 525. It is dead on. Do both sides. In fact, do all four corners. And if something isn't on, then something is wrong with the extrusion, or maybe it wasn't quite flush when you assembled it. And then finally, to make sure that these are square, measure the diagonal. So go from corner to corner the best you can. And it's really not that important what this should be as long as they match. So find a spot. I usually use the outside of the foot on the tape, and then I take it across to the top corner. I'll just hold my finger right here, take it across to the top corner. We have 810 to the very top corner on this side. So that means when we do it from this direction, it should be exactly the same. We'll take the foot of that tape, measure down. I actually have to push mine over on the table edge so I can get the tape to run out that far. And with a tape like this, it can be really hard to get it exactly where you need to, both sides, top and bottom, to measure that distance. But you could use a piece of string, a piece of filament. If you had a plumb bob with a piece of line in it, that would be great. But use anything you have to get that straight measurement. I happen to have just a piece of nylon filament right here. I'm just going to hold it at the very tip of that extrusion, take it all the way down to the tip and pull it tight, and I'll measure that. So we're at 820 millimeters, and then we'll do the same down here, the bottom corner. Again, the very tip of the filament, the very tip of the frame. If you still have your fingers in place, you're going to be able to tell that it's dead on if you have it square. You could even clamp this if you wanted to. Hold it up here. It's exactly the same length. Pull it tight, of course, but it's a little hard measuring diagonal with a tape, but you can get around it by doing a few tricks. And the same process for all sides. Do the front, the sides, make sure they're equal, distance across, distance diagonally. Do it to the back, and then you should have a really square frame. Again, it doesn't take much. Again, you can even use these little ones. Just put it in the corner. Make sure there's no gaps. Everything looks to be exactly where it needs to be. And you will have a nice square printer frame to start building some awesomeness. So there it is, a few tips and tricks to help you get your frame square when you're building your 3D printer. And remember, building your printer on a flat surface, something that you can trust, is going to help greatly. You don't have to do it that way, but it's going to save you a lot of measuring and adjusting to get everything as square as possible when you can trust that flat surface. And there's a lot of different ways to do this, I know, but this is the quick way that I know how to do it without spending a lot of money. Pretty much all you need is a carpenter square to be able to get everything lined up, and your 3D printer is going to work awesome first time when you're building it. So hopefully there was something in here that you found helpful. That is it for today, and I'll see you really soon on the next one.